Most music recommendation systems rely only on past listening history, but human preferences are dynamic. They depend on mood, environment, and context. So I built a multimodal music recommendation system that combines multiple real-world signals into a single intelligent pipeline. Traditional systems struggle when user intent changes. The same user may want calm music at night, energetic music during workouts, or emotional music in specific situations. This happens because most recommenders ignore real-time context. To solve this, I designed a system with 4 independent modules, each capturing a different modality of user context: emotion, weather, lyrics, and user behavior. Each module captures a different aspect of user context, and together they form a multimodal recommendation system. The first module, Vibe Sync, uses webcam-based emotion detection and an estimated energy signal to understand the user's current state and map it to song features like tempo, energy, and valence. The second module, Sky Sync, uses real-time weather data to incorporate environmental context into recommendations. It detects the user's location using IP-based lookup and fetches live weather conditions using external APIs. These weather conditions are mapped to mood categories. For example, rainy conditions map to calmer or more reflective music, while clear or sunny conditions map to more energetic or uplifting tracks. The system then filters songs based on this derived mood and includes fallback logic to ensure recommendations are always available, even when data is limited. The third module, Verse Sync, processes user input lyrics using natural language processing techniques like TF-IDF and cosine similarity to recommend semantically similar songs. The fourth module, Taste Sync, is the core recommendation engine based on collaborative filtering. Taste Sync is built using matrix factorization on the Song Dataset, which contains large-scale user song interaction data. Since the dataset is too large to load into memory, I implemented chunk-based sampling to efficiently process around 500,000 interactions. The data is then encoded into a sparse matrix, representing user item interactions. I use the alternating least squares algorithm from the implicit library to learn latent representations of users and songs. These latent factors capture hidden patterns in user preferences and song characteristics. During inference, the model recommends songs by computing similarity in this latent space, returning top beyond observed with confidence scores, and perform this well approach allows the sparse user data. Since the interaction dataset only contains song IDs, I map these IDs to actual track names and artists using the metadata file, ensuring the recommendations are interpretable and user-friendly. This step bridges the gap between model output and real-world usability. The system is built using a FastAPI backend and a NiceGUI frontend. Each module is designed independently, making the architecture modular and extensible. To ensure performance, blocking operations, like model inference and data processing, are executed asynchronously using thread pools. This prevents UI freezing and allows multiple requests to be handled efficiently. This design makes the system closer to a production-ready pipeline rather than just a standalone model.